Okay, so today we're graphing quadratics, and today we're looking at standard form. So there's three different forms with quadratics. There's vertex form, which we went over yesterday, how to graph in vertex form. And then there is what we're going to do today is standard form. So we're on green. Green is go. So today we're going over standard form. And tomorrow you're going to look at intercept form. So to find the vertex in standard form, you have to use this formula to find the vertex in standard form. So let's go ahead and start a problem. So in the very first problem, the first thing you want to do is you want to identify your A and your B. So instead of saying A is a decimal, just put it in as a fraction. You might go, but I hate fractions. You need to really work on how to work with fractions. And again, that you should not be using any calculator. So you'll watch and the fractions are going to go a lot easier. And then B is -4. So be careful, B is a -4. And we want you to do your work next to the graph. So we want to see your work. So on standard form, there's a formula that you have to use, and we want to see that formula being done. So we've got our vertex work. So to find the x coordinate of our vertex, we have to use the formula -b over 2a. And we said our b was -4, so it's going to be a -4 over 2 times -1/2. Right? So that's going to give me a negative times a negative, so that's a +4. And then 2 times a -1/2 is -1. So multiplying by 1/2 is easy. Half of 8 is 4. Half of 10 is 5. Half times 30 is 15. And then this gives us -4. So we now know our vertex is -4 something, right? So now we have to plug in -4 into the x. So we're going to plug in -4 wherever we saw the x. So we had, and again, I'm not going to use the decimal. I'm going to go back to the fraction. So we had -1/2 times x squared minus 4 times x plus 3. And we're putting -4 for the x values, right? We're plugging in -4 for the x values. And then we do order of operations. So PEMDAS says exponents first. So -4 times -4 is 16. Then I got to multiply that by -1/2. And then -4 times -4 is +16 here. And then half of that is going to be -8. And then 8 plus 3 is 11. So our vertex is -4, 11. So once we find our vertex, then we're going to create a t-table. So now that we have our vertex, we're going to do a t-table. So I'm going to erase this and get this out of the way. So we're going to have our t-table, and the very first thing we want to have is our vertex. So if you could please put V next to it, so I know in your t-table that that's the vertex. Actually, we can put it in the middle, or we could leave it there, that's fine. So -4, 11 is my vertex. So now what we want to do is we can plot it. So -4, 11 is my vertex, which notice I went by 2, so this is 2, 4, 6, 8. So -4, 11 is going to be right there, right? Because this is going to be 10. And now we want to pick, and then this is our axis of symmetry. So our axis of symmetry goes right through the vertex. So this is called your axis of symmetry. And we get tired of writing the words out, so we go AOS. And the equation for the axis of symmetry is x equals, right? Vertical lines are x equals, and then x equals -4. So that's the equation for the axis of symmetry. And this is our vertex. Is the parabola opening up or down? The parabola is opening down, right? So my parabola should be going down, so I know it's going to be going down. So now I want to pick, after we find the vertex, we basically want to pick 3 more points that are to the right or to the left of the vertex. So here's my vertex. So I want to pick either 3 points to plug and chug in my t-table to the right of the vertex. So I'm going to either pick points to the right of my vertex, or I'm going to pick points to the left of my vertex. It doesn't matter, but don't do some on the left and some on the right. And I'm going to pick to the right because it has 0 in it, and 0 is really easy to work with. So it's super, super smart. So we're at -4. So I'm going to plug in -2 into my t-table. And why don't I plug in 0 And I can even plug in, maybe +1. I can even plug in +1. And so now we're going to plug and chug. So I said I'm going to plug in -2. I said I'm going to plug in 0. And I said I'm going to plug in 1, right? Or I could even plug in +2. And now we're going to plug and chug and do our work. So now we have, I'm going to plug in -2. So down here is my plug chug work, right? My t-table work. And I go back to the original equation, which was -1/2 x squared minus 4 times x plus 3. And I said, let's plug in -2. And then we do order of operations. So this is going to be -1/2 times 4 plus 8, because we multiply that. And, right, exponents. And -1/2 times 4 is 2 negative. So that's 6, 3, so that's 9. Then we're going to plug in 0. So it's -1/2 times 0 squared minus 4 times 0 plus 3. And notice that gives me 0 and 0 and 3. So that's 0, 3. By the way, when you have 0 for the x, isn't that called your y-intercept? So notice when you plug in 0 for x, you're always going to have your constant's always going to be your y-intercept. And then let's plug in 2. So let's plug in 2. So -1/2 times 2 squared minus 4 times 2 plus 3. So that's 4, and then half of 4 is 2, and that's a negative. And then -4 times 2 is -8 plus 3. That's -10 plus 3, and that'd be -7. So this one gets -7. So let's plot those points. So we're going to plot -2, 9. So -2, +9 is right there. And then we're going to plot, now we're going to use symmetry. So if we were to fold this parabola, or let's go ahead and do 0, 3. So 0, 3 is going to be, there's 2, 0, 3 is right there. That's why I probably should have went by 1. So instead of going by 2s, I probably should have went by 1s, because it would be a little bit easier to be a little bit more accurate, but that's okay. And then 2, -7 is right there. So you can start to see half of the parabola, right? So to get the other half, this is like a fold line. Your axis of symmetry is a fold line. So imagine folding your parabola in half along this line, and those points would then mirror image on the other side. So this point is 1/2 unit from the fold line, so it would be 1/2 unit from the fold line on the other side. This point is 2 units from that axis of symmetry, or the fold line. So it would land 2 units on the other side of the fold line, because it's symmetrical. This point is 3 units, or 3 boxes away from the fold line. So this one has to be 3 boxes away from the fold line. Now you can see we have a nice parabola. When you're sketching your parabola, sometimes I have to turn my paper sideways to make sure that I get that nice sketch. Extend it past your point and put arrows, right? And remember, in SOPs, we talked about, having a half parabola like that is not acceptable. Having a tulip and like that is not acceptable. Having a parabola that goes like this and then goes straight are unacceptable, right? So we expect these parabolas to be decent. And it's hard for me because I have an iPad, so it's hard for me. But if I was using paper pencil, I could get a little bit better of a sketch, but that's not too bad, right? It's nothing super squiggly. Okay, so make sure you're drawing good parabolas and good sketches. And then what do we have? We have the top half. So notice that we have points that keep on going up, 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 up. So notice the y values keep on increasing, and then we reach its maximum height. So we say this parabola has a maximum height so how high does the parabola go? What's the highest it went? We said the highest it goes is maximum is 11, right? And then, we have our x-intercepts, right? These are called x-intercepts. So it's just reviewing a little bit of vocabulary with you. And then we have where it crosses the y-axis is the y-intercept. So you should know all different parts of the parabola. You should know the vertex. We should know whether it has a maximum or a minimum. We should know the equation of the axis of symmetry, the AOS, and its equation. And we should be able to identify the x-intercepts and y-intercepts. You don't have to identify them right now. We were just working on graphing, but you need to know the vocabulary. Okay, so what did we do? We made a t-table and we found our vertex. After we found our vertex, we picked some points either to the right of the vertex or to the left of the vertex, and we used those values in our t-table to plug and chug to get the rest of the t-table. And then once we plotted those points, we just mimicked those points on the opposite side. And make sure your points are nice and dark so we can see your points. Because if we don't see points, then we think you're just doing a sketch. And a sketch is not acceptable. So make sure your points are easy to see in a picture. Okay, let's try one more. Okay, so now let's go over the next problem. So here we have to find the vertex first. So when we're finding the vertex, we should be showing our vertex. So A is 1. So we're going to find the x value of the vertex. So we're going to do negative b over 2a. And a happens to be 1 and b happens to be 1. So it's going to give me negative 1 over 2 times 1. So the vertex is negative 1/2 something. So my vertex is going to be negative 1/2 something. So now to get the y value of the vertex, I need to take x squared plus x. And I need to plug in negative 1/2. And when you're multiplying and squaring, remember negative 1/2 times a negative 1/2 would be positive 1/4. And then when you're adding fractions, you have to have common denominators. So we're going to change this to 4. So basically we're multiplying top and bottom by 2. And then a positive 1/4 and a negative 2/4 is going to give us negative 1/4. So my vertex is negative 1/2, negative 1/4. If you're finding that your graph looks a little weird or funny, a lot of times what I notice it's the vertex that maybe you made an error with the vertex, either plotting it or maybe you made a sign error, something like that. So if you're finding that your graph doesn't really look right, go and look for a vertex issue. So now we're going to make a t-table, right? We want to see those t-tables. So we've got negative 1/2 and negative 1/4. Please, in your t-table, could you please state which one's your vertex so I know that that's your vertex? So we're going to plot that. So this is negative 1, and half of that is negative 1/2, and half of a half is negative 1/4. So we need to come down to negative 1, negative 1/4 is about right there. And then remember your axis of symmetry goes right down the middle. So maybe I shouldn't have went by ones. Maybe I should have went by 1/2, right? So there's where some of our decision comes into maybe going by halves instead of ones. Now we're going to go to the t-table. So when we go to the t-table, we want to pick 3 more points either to the right or to the left of the vertex. So in this particular example, I'm going to pick 3 points to the right of the vertex. So you're going to pick either 3 points to the right of your vertex or 3 points to the left of your vertex. And since the right side has 0 in it, I'm going to pick the right side because that's easy to work with. And not only that, when you pick 0, isn't that your y-intercept? So when you have 0 for your x, doesn't that mean this coordinate is going to be a y-intercept? That's important to know. And then I'm going to maybe pick 1 and pick 2. So let's see what happens. When I do 0 squared plus 0, I get 0. When I do 1 squared plus 1, I get 1. And when I do 2 squared plus 2, I get 4 plus 2, I get 6. So this is 0, this is 1, and this is 6. And so I'm going to plot those. So 0, 0 is right there. 1, sorry, this is going to be 2. 1, 2. Gotta be careful. So notice if I would have made that mistake, my parabola would look weird and it wouldn't really look like a nice parabola. So you'd have to go look for errors. So if your parabola is not looking right, go look for t-table errors or vertex errors. And then we said 2, 6. And then we're going to mimic them because they have, right, it has symmetry. So this one is a half a unit away from the fold line or axis of symmetry, so this point should be a half. This one is 1.5 units away from the fold line, so it should be the same distance on the other side. This one is 2.5 away from the fold line, so this one should be 2.5 away from the fold line. And then I need to turn my sideways so I can go down and get, so it helps me if I kind of turn my paper sideways so I can get a decent parabola in there. So I'm turning it. So remember, we should have no tulips, no V's. We should have symmetry, so that's not okay. We shouldn't have a parabola with a U and then saying it goes straight up. That's another one I see a lot. So we should have a nice straight parabola with no tulips and nice decent parabola. Okay, axis of symmetry. So remember, your axis of symmetry is the fold line, and that's where it has, and that equation is x equals, because it's a vertical line. We just left that, right? Vertical lines are x equals something, and horizontal lines are y equals. Axis of symmetry is a vertical line, so it should be x equals. You can't, and you have to write the equation. You don't just say -1/2. You have to write the equation that goes with that vertical line. And then do we have a maximum or a minimum? So this particular parabola, what's the lowest it goes? So the lowest it goes is right there is the vertex. So the lowest it goes, so we say it has a minimum, and the lowest it goes is -1/4. So it has a minimum of -1/4. We should be able to know where the y-intercepts are, right? This y-intercept happens to be right there, and we should also know the x-intercepts. So we should know that vocabulary. Okay. And just one last thing, let's just go over identifying A, B, and C. So remember, when you're looking at a standard form, you have y equals ax squared plus bx plus c. The ax squared is called your quadratic term. The bx is your linear term. And the c is your constant term. So, whoops, I forgot my squared in this problem, so let's add a squared right there. So the a in this problem is 4, the b is -1, and the c is 0, right? There is no c. So we have our quadratic term, our linear term, and we have no constant. In question B, our quadratic term has a coefficient of 2. Notice there's no linear term. There is no ax or bx term. There's no linear term. So here we'd have to, b would have to be 0, and the linear term, or the constant term, is 7. So we should know our vocabulary: quadratic term, linear term, constant term. So what if we had to find the vertex for this problem? If we had to find the vertex for this problem, wouldn't we do -b over 2a? And isn't the b 0 in this problem? And so that would be, so -0 is just 0, and 2 times 2 is 4. And remember, any number divided by 0 is 0. So, and then once we plug that in, that would give us 2 times 0 squared plus 7. And that would give us, our vertex would be 0, 7. Okay. So that's it. Make sure you're showing your work. Make sure you have all your T-table work.